Hello, this is Scott. So today we're going to be talking about stress testing, defect testing, and QC for attributes. So in this example, what we're going to do is we're going to assume that we're manufacturing light bulbs, and we want to evaluate individual bulbs and their operation under different conditions. So what we have is we've drawn a lot of different samples, and each sample contains 100 bulbs, right? So simple random sampling, a good controlled experimental technique. And then we're going to perform the stress test on each bulb and look at non-conforming units, right? So basically a variable defect. So the data is in Statistica open examples and then data sets. And then if I go to the bulb data set, and so this is a very simple data set, and I have 30 cases here. And so this is actually the number of defects for each sample. And again, the sample size is 100. So we go to statistics, QC charts, directly into QC charts, and then I'm going to do a P chart for attributes. Now, you have different options to select here, right? I could select proportions or raw data, but since our data is already is count data, I'm going to set it here as counts. I'm going to say that we have a constant sample size and that we have 100 units per sample. So it's really that simple. But no, you can create your own sets. You can create all of the different options within the platform itself. So defects is going to be our counts or proportion variable here, and boom, there we go. We've got our control chart for attributes, percent non-conforming within Statistica. And so we can see here that based on this data, I have no defects that are beyond 3 sigma. We'll get to their spec limits and control limits in just a second. But one of the things that I can do in addition to this simple 3 sigma is I can look at the runs test. So I can do like Schuhart and Westinghouse type run rules, right? So here we can see that I do have an issue. Let me close this, minimize this, and then I can see that in fact there was a run from sample 20 to sample 21 where I had 3 samples out beyond the control limits there. So that's how I can get to the individual run rules that I have. I can also change spec limits. So let's suppose that I've determined, just for illustration, that this is in control. Obviously we can inspect this. Please see the other videos on brushing and how I can go through and assign cause and actually reset my control limits based upon removing certain values if I have determined an out of cause, an out of control issue that's explainable. I can basically denote that and rerun it. So let's suppose that we did that, and we would now want to set our upper control limit for our specs instead of based on a sigma, that I want to set it on a KPI or performance measure, and I can do that. Click that, and all I have to do is update the chart here, and it's updated. So anytime that you want to update the charts, you can do that. Also, we've covered brushing and other elements in previous videos. I hope that you see those and that you'll join me again. Again, so this was the stress testing, defect testing. Here's a couple ways to contact me if you have comments or ideas for the series. This is Hands-On Statistica. Thank you very much for your time. We'll see you again next